I'm going to discuss how to find least common denominators with regards to rational expressions. The procedure is going to be similar to the prime factorization procedure one could use for numerical denominators. All right, so let's do an example. Suppose that I had a denominator of 16x and another denominator of 8x cubed. Let's find the prime factorizations of the numerical pieces and bring the variable pieces along for the ride. So 16x, that's equivalent to 2 to the 4 times x. 8x cubed, that's equivalent to 2 cubed times x cubed. Now, notice that the first blue product has 4 2's and an x. The second blue product has 3 2's and 3 x's. So we need to find a product that includes all the pieces in both blue products. So a product that has 4 2's and 3 x's contains the original 2 blue products in it. So this is the least common denominator, and if you like, you can write it as 16x cubed. All right? Let's do a little bit more involved one now. What about if we had these two denominators, 50x cubed y squared and 20x squared y cubed. So once again, we're going to find the prime factorizations of the numerical pieces and then bring the variables along for the ride. So let's see, 50, that's 25 times 2, 5 squared times 2 times x cubed times y squared. And then 20, the prime factorization of that, let's see, that's equal to 4 times 5, so 5 times 2 squared. And then we tack on the x squared y cubed. Now we find a new product that contains all the pieces of both of those blue products. So we need 2 5's, we need 2 2's, we need 3 x's, and we need 3 y's. Okay? Now we can write that as 100x cubed y cubed, and that is the least common denominator for that example. All right? Now, if you have two denominators that are, if one or both are not factored, you have to factor them first before you can apply this procedure. Okay, so let's do an example that is not factored. Suppose you had these two denominators, x squared plus x minus 12 and x squared plus 2x minus 8. So as I said, we first have to factor. So what would the factorization of the first piece be? I'm going to go with x plus 4, that binomial times the binomial x minus 3. And for the second quadratic expression, I'm going to go with x plus 4 and x minus 2. Okay, so just like before, we're going to find a new product that contains all the pieces of the two blue products. So we need x plus 4, we need x minus 3, and we need x minus 2. That includes all the pieces. And you could expand out this product. I'll leave that as an exercise if you wish, but you can also just leave the least common denominator as shown. All right? Now, you can also find the least common denominator of 3 or more denominators. And that is the same procedure. So let me have you do an example with 3 denominators. All right. X squared minus 2x plus 1, x squared plus 11x minus 12, and 1 minus x. Pause the video and see if you can find the least common denominator of these 3 denominators, please. All right, I will go ahead and show you how I would work this out. So first I would factor. So let me do that. The first one I would get x minus 1 squared. The second one I would get, let's see, x plus 12x minus 1. Now, the last denominator is already factored. However, we really wish it had an x minus 1, because if it did, then it would have a piece that was already contained in the other prime factorizations, in the other red products. So what we can do is rewrite that, you'll hopefully remember, as minus the binomial x minus 1. Okay, so putting it all together, or finding a product that includes all the pieces of the 3 red products, we need 2 x minus 1 binomials. We also need an x plus 12. We can ignore the minus sign. All right, 1s and minus 1 factors are not necessary in least common denominators. All right, so then this is the final answer.